Yes, good morning.
Good morning.
Good morning.
Yes, welcome for our lesson today. So before we start our new topic, first topic for Form 2, I'd like to remind you some few things which will assist us when it comes to this topic. So we looked on, well in Form 1 now we looked on define what an atom is, define also what an element is, what a compound is, and what a molecule is. So you can remind yourself when it comes to those definitions, since in most of the cases, though we are going to use those terms when it comes to this topic. So who can define for us what an element is? What is an element? Who can remind us? Yes. Yes, who can remind us? Yes, Godwin.
Elements are pure substances that cannot be split further into simpler substances by chemical means.
A good attempt. Thank you. That is a very good. That is good. Who can also define for us what a molecule is? What is a molecule? Godwin again.
A molecule is the smallest particle of an element that can exist separate.
Thank you. So an element is a pure substance which cannot be split into simpler substance by chemical means. And we gave out various examples. We gave out various examples. Remember, we wrote the first 20 elements when we were in at Form 1. So you can be able to list any of those. Then we also said that an element is made up of atoms, and we say an atom is the smallest particle of an element which can take part in a chemical reaction. We said that, we also said the atoms of the same element cannot exist independently, but they also join together to form a small group of atoms. Now that small group of atoms is what we call a molecule. Therefore, we say a molecule is the smallest particle of an element or a compound which can exist separately. And in that, we gave out examples of molecules. We have oxygen molecule, nitrogen molecule, we have hydrogen, chlorine, and fluorine. Then we also went ahead and looked on compounds, whereby we say a compound is a pure substance that consists or made up of two or more elements combined chemically. So we also gave out an example. We have an example of element compounds. So we have sodium chloride, iron 2, sulfide, calcium nitrate, calcium carbide. We have sodium hydride, sodium sulfate, calcium nitrate, potassium chloride, water itself. Give many examples of compounds. So in this case now, when it comes now to form 2, this first topic, that is the structure of an atom and the periodic table. Our major concern is to look on the atom now. Atom, then later we are going to look on the other elements, the elements. Now, in this case, we are going to, our major concern now will be by the end of the topic, we shall have attained some of the objectives. That is the topic objectives. That is the atomic theory. Then we have the structure of the atom, characteristics of the atom, the periodic table, and formation of an ion. So by the end of this topic, shall have attained 5 objectives. Objective number 1, atomic theory. Objective number 2, structure of the atom. Number 3, characteristics of the atom. Then the periodic table, and lastly, formation of an ion. So those are the topic objectives. By the end of the topic, we shall have attained all the 5 objectives. Now, let's look on now the atomic theory. Atomic theory, this is actually the theory that tries to explain the origin of an atom. And this theory is being suggested by the scientist that is Dalton. Dalton is the scientist who came up with the theory, of an atom, After conducting the experiments, he came up with the structure of an atom. Therefore, we said, Leslie, Elvis.
Is it Job Dalton or John Dalton?
It is John Dalton's atomic theory.
But I read in another book it says Job Dalton.
John Dalton.
Job Dalton.
Yes. Yes, what I can only say, that is just the same name, but Dalton is the surname.
Okay.
Yes. So the Dalton came up with some of the suggestions. He made some of the suggestions which he said an element is made up of small particles, and these small particles we call them atoms. And also he said another suggestion he made that the atoms of a given element have properties which differ from those of other elements, meaning the atoms in a given element have the same properties. So meaning the atoms in for example, in oxygen, in sodium, they have the same properties than those of magnesium, they have the same properties, meaning the atoms of individual elements have the same properties. So meaning the atoms in sodium have different properties, and those for magnesium have different properties. So the atoms of the given element have properties, and these properties differ from one element to another. Another suggestion made, the atoms cannot be created, destroyed, or transformed into atoms of other elements. Meaning, what that statement means, the atoms of a given element cannot be changed to be atoms of another element. Meaning, the atoms cannot be created, destroyed, or transformed into atoms of other elements. So meaning you cannot change the atoms of sodium to become the atoms of magnesium. That is what that point simply means. Another suggestion he made, the compounds formed when atoms of different elements combines with each other in a small whole number ratio. Meaning, when these atoms combines together, they form compounds. They form compounds. When once they combine at a given ratio, that is at a given ratio, then to form a compound. And lastly, he said the relative number and all the kinds of atoms are a constant in a given compound. Meaning, the ratio of a given atom in a compound remains the same. Then those are the suggestions that made by Dalton after conducting some of the experiments. Then after conducting the experiments, he came up with those suggestions, and therefore he suggested that an atom comprises of an atom, and they come up with an atom. And therefore, let's look on the nature of the atom. And at the nature of the atom, it is actually, we are going to look on the structure of an atom. The structure of an atom. So under the structure of an atom, before we move on now, we can be able to, from basing of this on the suggestions that were made by Dalton, then we can be able to say an atom is the smallest particle of an element that can take part in a chemical reaction. Smallest particle of an element that can take part in a chemical reaction. Therefore, we can say, now if we look on now an atom, the structure, an atom is made up of small particles, and these small particles, we call them subatomic particles. And these particles, there are three. We have the electrons, the protons, protons, and neutrons. So the atom is made up of two regions. We have the small central part, that is the nucleus, and the other region surrounding the nucleus. Now, in the nucleus, that's where we have the protons and neutrons. And therefore, the protons and neutrons are being referred to as nucleons because they are being found in the nucleus. Then the other region surrounding the nucleus, it consists of the electrons. What am I trying to say is this? If you look on the structure of an atom, it is made up of two regions. It is made up of two regions. Let me try to do something here so that you can be able to see. So look on this. this is the structure of an atom. This is the structure of an atom. We said an atom, it is made up of two regions. We have the central part. This is the central part, that is the nuclear. Then now in the nuclear, that is where we have the protons and the neutrons, and therefore the protons and the nucleus, we call them the nucleons. So this is the protons, these are the neutrons. Now the other region, the region now that surrounds the nuclear, it is being occupied by electrons. It is being occupied by electrons. So that's why we say the nuclear, the atom is made up of two regions. The smallest central part, this one, that is the nuclear, consisting of the protons and the neutrons. Then we have another region, the larger region, that is being occupied by the protons. We have the neutrons and the electrons. We call them subatomic particles. Subatomic particles, meaning these particles, they are being found in an atom, but in different regions. As we have said, neutrons and the protons and the neutrons being found in the nuclear, and the other region that is being occupied by electrons. Now let's move on. That is the structure of an atom, and let's look on now the various examples. Let us look on various examples. Let's say this hydrogen atom is the simplest in composition and has one proton and one electron, but has no neutron. What we simply mean there, if you look on a hydrogen in periodic table, it is atomic number 1. It is atomic number 1. So if you look on the structure of it, hydrogen, it has one proton but has no neutrons, and it has only one electron. So these are the protons, these are the neutrons, then these are the electrons. So if you look on the structure of it, it has one proton and it has one electron, but has no neutrons. So meaning it has only one proton and one electron, but it has no neutrons. Let's look at another example of helium. Helium, you look on the helium on the periodic table, it is position 2, is atomic number 2. So if you look on it, it has 2 protons, 2 electrons, and 2 neutrons. So if you look on the structure of it, you will have 2 protons, 2 neutrons, and 2 electrons. and 2 electrons. So that is the structure of an helium atom. So if you look on that, that's 2 protons, 2 neutrons, and 2 electrons. So we say protons are positively charged. Protons are positively charged. Electrons are negatively charged, while neutrons have no charge. Neutrons have no charge. From this example, what can you say? Look on the example I gave you for hydrogen and the one for helium. I said hydrogen, it has 1 proton and 1 electron. And in another example, and the other example of helium, I've just said helium, it has 2 protons and 2 electrons. So from the above, what can we be able to say? Can be able to say, if you look on the 2 examples I've just given you, is that can say the number of protons and the number of electrons are the same, are equal. Look on the example of hydrogen and look on the example of helium. I've just said for hydrogen, it has 1 proton, 1 electron. For helium, that's 2 protons and 2 electrons. Then we can just, from that we can be able to say the number of protons is equal to the number of electrons for any given atom. Therefore, this makes the atom to be electrically neutral. So meaning the protons and electrons contributes to electrical conductivity of an element, of an atom. We are going to come up with that. Since the neutrons have no charge. So you can also say hydrogen atom has 1 proton. That is what we have just said. While helium atom has 2 protons and 2 electrons. Then the neutrons in the nuclear contributes to the stability of the nuclear. Why does the nuclear neutrons contribute to the stability of the nuclear? Because if you look on the neutrons, they don't have any charge. So let me display then we can be able to move on. So that is actually what we have said. That is what we have just said. Before we look on now the energy levels in an atom, let's look on the chemical symbol of the elements, the chemical symbol of the first 20 elements. And once we know now the chemical symbol and the atomic number for the first 20 elements, then we can be able to move on electron and energy levels and electronic arrangement. Energy levels and electronic arrangement of the first 20 elements. So let's talk about the chemical symbols of the elements. And in this case, we are going to look on the first 20 elements. That is something we did. When we were looking on the elements, atoms, compounds, and molecules. So a chemical symbol of elements. This is the simplest way of representing elements. and each element is being represented by a chemical symbol. And this chemical symbol, the chemical symbol, it may consist of one or two letters, may consist one or two letters. In case an atom or an element has one letter, the chemical symbol is one, then the letter must be capitalized, meaning the letter must be written in capital letters. And when the chemical symbol consists of two letters, then the first letter must be capital and the second one must be small letter. So those are some of the symbol rules that we need to follow when writing the the chemical symbol of different elements. So one, if an element has one letter, the chemical symbol is one. Then, for example, we have the case of hydrogen. So for the case of hydrogen, that is one letter. We have H. Therefore, it must be written in capital letters. Then in the case of phosphorus, so P must be written in capital letters. In the case of sulfur, S must be written in capital letters. In case of fluorine, oxygen, nitrogen, carbon, boron, and boron. So all those you must write them in capital letters. So those elements consist of one letter. Their chemical symbol consists of one letter. Therefore, you must write that in capital letters. When it comes to those elements with chemical symbol consists of two letters, like an example of helium. So the first letter must be capital and the second one must be small. So in that case, H must be capital and E small letter must be in small letter. And the case of lithium, so L must be capital and I must be small, should be in small. Then we have beryllium. Same case happens to beryllium. Same case happens to neon, sodium, magnesium, aluminium, silicon, chlorine, argon, and lastly calcium. You have other elements like copper. We have zinc, we have lead, we have gold, we have Crampton and the others and the others. So when writing the chemical symbol of elements with two letters, there must be, the first one must be capital. So my dear students, I think I gave you the formula for writing the chemical symbol for the first 20 elements. So you can remind yourself, you write the first 20 elements, you write their chemical symbol and you write their chemical symbol. We're giving you some 5 minutes. You write the first 20 elements, then their chemical symbols. Are you through?
Yes.
Now, from from number one element, number one atomic number one to the to 20. So we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So those are the first 20 elements, their chemical symbol, their chemical symbols, and their atomic number. So meaning atomic number.
Excuse me, teacher.
Yes.
What is the chemical symbol for argon?
For argon, already I have displayed the chemical symbol for argon. Have you seen?
Yes, yes.
AR.
Yes. So those are the chemical symbols for the first 20 elements. For the first 20 elements. So for, I think you can be able to see hydrogen there. We have element. Then I get a symbol. Leave about the shell number. Leave about that. We are coming to that. So for hydrogen, you can be able to see helium. We have you can be able to see the chemical symbol for the first 20 elements as I've displayed there. So let's look on the atomic number and the mass number. The atomic number and the mass number. Atomic number is the number of protons in the nucleus of an atom. The number of protons in the nucleus of an atom. Atomic number is the number of protons in the nucleus of an atom. For example, we said hydrogen atom has 1 proton in the nucleus. Therefore, its atomic number is 1. What we have said, the example I gave you for hydrogen, I said hydrogen has 1 proton and 1 electron, but it doesn't have a nucleus. So if you look on that example, hydrogen has 1 proton and 1 electron. Therefore, we say the atomic number is the number of protons in the nucleus of an atom. And therefore, since the number of protons and the number of electrons are the same, therefore, we can also say atomic number is the number of electrons of an electron, or number of electrons in an atom. Remember, electrons are not being found in the nucleus. They are being found in the structure of an atom. Therefore, we say atomic number of electrons in an atom. So we can define atomic number in 2 ways. Number of protons in the nucleus of an atom, or number of electrons in an atom. Then we have the mass number. The mass number is the sum of protons and neutrons in the nucleus of an atom. Sum meaning the total number of protons and the neutrons in an atom. Remember, we said the protons and the neutrons are being found in the nucleus of an atom.
So the total number of protons, we add the total number of neutrons, then it will give us the mass number. The mass number. And therefore, we say mass number is the sum of protons and neutrons in an atom. In an atom. For example, an atom of hydrogen has 1 proton and has no neutron in this structure. And therefore, the mass number is 1. The mass number is 1. The mass number is 1. Let's look at another example of helium. I gave you another example of helium. Helium atom, it has 2 protons and 2 neutrons. Therefore, its mass number is 4. That is, 2 plus 2 will give us 4. Then, let's move on and say, but the mass number and atomic number can be written along the chemical symbol of an element. Meaning, for example, if you can be able to look on this, look on this. For example, let's take an example of hydrogen. Let's take an example of hydrogen. We want to represent element and it is atomic number and mass number. Hydrogen, it has one proton. It has 1 proton and 1 neutron, 1 electron. So we can present is like this and this. So meaning it has a mass number of 1 and atomic number of 1. How do we get the mass number? Mass number, it is the sum of protons and neutrons. So the number of protons and the neutrons will give us the mass number. Therefore, in hydrogen, we said hydrogen has 1 proton but has no neutron. Therefore, it will give us the mass number of this. Atomic number. Atomic number, we say, is the number of protons or electrons in an atom. If we talk about now the number of protons, we simply protons are being found in the nucleus of an atom. But if we talk about the electrons, they're being found in the structure of an atom. Therefore, this is the atomic number and this is the mass number. Therefore, the mass number is being represented as superscript in front of the chemical symbol. For hydrogen, it is like this. For hydrogen, is like this. That is the mass number. But now, the atomic number is being represented as subscript. This one. Upper chain. So let me give you another example, which is more, which is actually you can be able to get it clear. Let's look on the example of sodium. Sodium sodium has 11 protons and 12 neutrons. It has 11 protons and 12 neutrons. And we said mass number is the total number of protons and the neutrons. So it is 11 plus 12, you get the mass number, which is 23. And mass number is being represented as superscript in front of the chemical symbol. So that is 23. Then remember, the atomic number we said is the number of protons, which is 11. So we present this. So this is the representation. I've represented this element, this sodium. I've presented it is mass number and it is atomic number. So mass number is 23. Atomic number is like that for different elements. Then also let me give you another example of magnesium. If you look on magnesium, it has 12 protons and 12 neutrons. 12 protons and 12 neutrons. Now, what is the mass number of it? What is the mass number?
20.
That is good, 24. So the mass number for magnesium is 24. Then the atomic number is 12. 12. Another example for aluminium. Aluminium has 13 protons and 14 neutrons. What is the mass number?
27.
27. That is good. That is good. That is very, very good. Another example, neutrons. What is the number? Thank you. That is good. Another example is for calcium. Calcium has 20 protons and 20 neutrons. What is the mass number?
40.
That is good. Then for carbon, carbon has 6 protons and 6 neutrons. Then what is the mass? What is its mass number?
12.
12. 12.
Yeah. That is good. That is good. So I think you can be able to make to calculate the mass number and atomic number of different elements. Now this is what you do. Make a table of how many columns? Make a table of 7 columns. Make a table of 7 columns. Make a table of 7 columns. We need to do something here. Make a table of 7 columns. Okay. Make a table of 7 columns. Are you through? The first column, like elements. Then you write the first 20 elements. I've said in the first column, you write on top, you write elements. Then you write the first 20 elements. The second column, you write the symbol, chemical symbol. The second column, you write the chemical symbol. The third column, you write number of electrons. The fourth column, you write number of protons. The fifth column, you write number of neutrons. Number of neutrons. Then the sixth column, you write the atomic number. And last column, you write the mass number.
Can you repeat?
Yes, I'm saying the first column, you write elements. Then you write the first 20 elements downwards. Then the second column on top, you write the symbol, the chemical symbol. Then the third column on top, you write number of electrons. Then the fourth column, you write number of protons. Then the fifth column, you write number of neutrons. Then the sixth column, you write atomic number. And the last column, you write the mass number. So have you written that? So under the symbol, you write the symbol of the elements that you wrote in the first column. So if it is hydrogen, you write it is symbol. Helium, you write it is symbol. Lithium, like that, up to calcium. Are you through? Most of us.
Yes.
The number of electrons, the columns for number of electrons. Are we down 4? Boron, you put a dash. Sodium, you put a dash. Magnesium, you put a dash. Aluminium, you put a dash. 14. Phosphorus, dash. Sulfur, 16. Chlorine, 17. Argon, dash. Potassium, 19. Calcium, dash. Now, are you through under that column for number of electrons?
Yes.
Yes, let's move to another column, number of protons. So you write for hydrogen 1, 2, helium, 3, lithium. For beryllium, 4, boron 5, carbon 6, nitrogen 7, 8 oxygen, fluorine 9, neon 10, sodium 11, magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, potassium 19, and calcium 20. Column for number of neutrons. Number of neutrons for hydrogen is 0, helium 2, lithium 4, beryllium 5, boron dash, carbon dash, nitrogen 7, oxygen dash, fluorine dash, neon dash, sodium 12, magnesium 12, aluminium 14, silicon 14, phosphorus 16, sulfur 16, chlorine 18, then argon 22, potassium 20, calcium 20. Atomic number. You can fill the column for atomic number. Fill the column for atomic number. That is 1, 2, 3, 4, up to 20. Yes, Aaron?
I wanted to ask why some elements have dashes on the electrons and neutrons.
That is whereby you are supposed to fill. You are supposed to fill.
Okay.
Yeah, you are supposed to fill. Just fill the column for atomic number. Then mass number, I'll take you through the mass number. Then the rest you can be able to fill.
Tunaweza kufill. Dunia yako hapa na guess vitu gani? Like tunafaa kujifilia, lakini sasa mimi niko na kitabu mimi siko najua.
Kunajifiliaje sirudi bado?
Like ufill number of electrons kwa hii atom.
Oh, sawa, lugha nataka kuandika hapa na
So are you through with the column for atomic number?
Yes.
Yes, let's move on to the column for mass number. We said mass number is the number of protons. You add the subtotal of number of protons and the neutron. So for hydrogen, it is 1 plus 0. You get 1. So under mass number for hydrogen, you write 1. For helium, the number of protons is 2 and the number of neutrons is 2. So the mass number, it is 2 plus 2, which is 4. You write 4. For lithium has the number of protons is 3 and the number of neutrons is 4. So the mass number is 3 plus 4, which is 7. So you write 7. Beryllium, number of protons 4, number of neutrons 4. So the mass number is 8. 4 plus 4, which is 8. For boron, the number of protons is 5. The number of neutrons, I gave you a dash there. So the mass number is 11. And the mass number, you write 11 for boron. For boron, 11. So how can you be able to find the number of neutrons? It is the mass number, you subtract with the number of protons, then you get the number of neutrons. So it is the mass number, which is 11. You subtract the number of protons, which is 5. Then you get the number of neutrons, which is what? 6. For carbon, the mass number is 12. The mass number is 12. Then the number of neutrons is 6, and the number of protons is 6. For nitrogen, nitrogen has 7 protons and 7 neutrons. So the mass number is 14. For oxygen, under the number of protons, I give you a dash there. Then the number of neutrons, I also give you a dash there. So the atomic number is 8. Then the mass number is 16. So meaning it has 8 protons and 8 neutrons. Fluorine. Fluorine, for the number of protons, I gave you a dash. Then the number of neutrons, I also give you a dash. But the atomic number is 9, and the mass number is 19. So for us to get the number of protons, it is the number of protons, which is the number of protons. The number of protons, which is 9, and the number of neutrons, which is 10. So it is 19. You subtract 9, you get the number of neutrons, which is 10, and you also get the number of protons, which is 9. Neon. The mass number is 20. So under the column for mass number, you write 20. Then the atomic number, which is 10. So for us to get the number of neutrons, it is 20 minus 10. Then you get 10. So the number of protons also 10. Sodium. The number of protons which is 11. The number of neutrons 12. Atomic number 11. Mass number, that is 23. That is 12 plus 11, you get 23. Magnesium. Number of protons 12. Number of neutrons 12. Atomic number 12. Then the number of the mass number, which is 24. 12 plus 12, 24. Aluminium. Atomic number 13. Then we have the number of protons, that is 13. Number of neutrons 14. Atomic number 13. Then how can we find the mass number? This is the number of protons plus the number of neutrons. That is 13 plus 14. It will give us 27. Silicon. Number of protons. Yes. My internet is having some issues, but I'm back again. Now we were under silicon. Let's start from silicon. Silicon, we said we have the number of electrons, that is 14. Number of protons, 14. Then the number of neutrons, 14. Atomic number, 14. then mass number 28. Phosphorus, number of protons 15, number of neutrons 16, atomic number 15, then the mass number 31. That is 15 plus 16. Sulfur, number of protons 16, number of neutrons 16, atomic number 16, then the mass number 32. 16 plus 16, which is 32. Chlorine, the number of protons 17, number of neutrons 18, atomic number 17, then the mass number is 35. That is 17 plus 18. Argon, we have 18, number of protons 18, the number of neutrons 22, the atomic number 18, then the mass number 42. The mass number is 40. Sorry, the mass number is 40. That is 18 plus 22, which is 40. Potassium, number of protons is 19, number of neutrons 20, then atomic number 19, then mass number 39. That is 19 plus 20. Calcium, number of protons 20, number of neutrons 20, atomic number 20, the mass number 40. Now, have you filled the table now? Is the table now complete?
Yes.
There is a section that is not complete under the number of electrons. So you fill there now under the column under the number of electrons. Since the number of electrons is the same as the number of protons, so fill the gaps. Fill the gaps for some elements. Fill the gaps. Are you through? Are you through, my dear students?
Yes.
Now, from the table above, being given the mass number and the number of neutrons, you can be able to calculate the number of protons. The same thing, being given the number of protons, number of neutrons, you can be able to calculate the mass number. Same thing, being given the mass number, you can be able to calculate the number of protons. So that table, it's actually enables us to calculate the number of protons and the number of neutrons and the mass number, being given one of each. The two of them you can be able to calculate. So I think up to the moment you can be able to calculate the mass number, being given the number of protons and the number of neutrons. So from the definition for mass number, we said the mass number is the sum of protons and neutrons in an atom. So the number of protons and you add the number of neutrons, you get the number, the mass number. And the mass number is being represented as superscript, while the atomic number is being represented as subscript. And we say atomic number is the number of protons in the nucleus of an atom, or is the number of electrons in an atom. So if you look on that, number of electrons and the number of protons is the same, is the same, is the same, is the same. So that's why we say the number of neutrons, I mean the number of protons and the number of electrons are the same, are the same. And this one contributes to electrical, makes the atom to be electrical neutral, electrically neutral. So if you have any question, if you can ask the question, where you need some clarification, ask the question. Okay, there being no any question, meaning people have understood that the concepts. Now, write this work down. Write this work. Write the atomic number of chlorine is 17, and its mass number is 35.
It is.
I've said the atomic number for chlorine is 17, and its mass number is 35. Represent the element. Present the element showing the atomic number and the mass number. Nani anaandika hii haraka sana? Very simple one. You write the chemical symbol of the element, then you represent the mass number and the atomic number. Niki Kimathi. Nick.
The postulates of the Dalton theory. I didn't finish writing.
Yes. You didn't finish writing what? The table?
No, not the table. The left out number 3.
I'm not getting you clearly. Maybe your network is having some issues. Then you can text. Text. The rest mumeandika hiyo. So it is actually you write the chemical symbol for chlorine, then you represent the mass number and the atomic number. As we did the same thing we did for sodium, and the other elements there. So in our next class, that is when in our next class we are going to look on the isotopes, the energy levels, and the electronic arrangements. Then we are going to do various examples there. The various examples there, then we can be able to move on to period and the periods and the groups. That is the periodic table. We discuss much on it. Then we move on to the onto the relative atomic mass. After that, then we move on to the formation of ions. Then we look on radicals, oxidation numbers, and lastly we look on the oxidation states, chemical formulae, chemical equations. Then we are through with that topic. So let me display the notes, the one. So there is a problem in connection. So maybe I'm not the host so that I can share. Remember my internet cut off some few minutes ago. Then I rejoined, but now I'm unable to share. So what I'll do, then the notes with Mwalim. You can inbox me, then I can share the notes to you. You can just inbox me, then I can share the notes with you. Otherwise, I wish you very best. Let's adjourn our lesson. We meet in our next lesson. Otherwise, I wish you very best as we meet, as we approaching to opening our schools. We meet face to face, then we can do work thorough as the way we used to do. Otherwise, I wish you very best and you greet your parents.
Kuja break.
Thank you, Mwalimu.